there are, I would say, like three. Yeah, for this presentation, I've added three main points for like how the Basel. I mean the three main features of Basel. So one is the Basel workspace. So this is how we add our rules and how we structure our code base. I think I'll share a bit of our example here. So I have added how can I so I've added two separate projects with different languages, and so a project should start with a workspace, and I'll explain this later how this works. And then each project should have a build file. So this is where we put our build rules. So if you're familiar with CI, continuous integration, then so I think the idea of continuous integration is to avoid breakage of the code base as changes come in, because if we are working on a, like for example, a service that that contains, or no, that is like, if there are like multiple developers working together for a single service, then we need to have checks for every change that the developers like is adding. So that's where this CI comes in. So to ensure that tests are working, the code base structure is followed, and coding rules are followed. So this is where we put those things to the build file. And then so the second one is the Basel Cache. So if you have noticed that if the number of like projects scale, like for example, we have 50 projects in one repository, then running all of the checks will be a nightmare, right? So it's going to take time to finish those things. So what Bazel has done is, in order to have its own like targeting mechanism, for example, we've only added changes for based on this example, we have only added changes for the node project. Then the node project should only be the one that runs in the CI build. So I'll demonstrate here a bit of of it. So you have two projects that has like test rules in it. So a test rule runs the unit tests for every project. So if you are familiar with like Agile and TDD, so it's good practice to put tests for every feature that you add into the code base. So we've added one test for this for demonstrations purposes. So I think this shows how the tests are run. I'll disable things a little bit. Okay. So this one. So I think if we'll change something in the Node.js project. So Bazel detects changes in the files. So as you can see, there's one running. So the node test passed, but this one, it says cached, right? So it doesn't run the Python project, only the Node project. So that's how Bazel does its targeting mechanism for like targeted builds. So the entire builds, the entire, like all of the projects builds will not run, only the specific ones, the ones that you added change in the development. So next, so we've also experienced certain problems with caching. Um, so as the project grows or the code base grows, caching locally, like for example, we just maintain our cache in the CI, like GitHub Action CI. So the cache grows, and as the cache grows, the cache checking slows down. And in order for us to mitigate that problem, uh, the next like the next step is to use remote execution, and we can have like many workers to deal with the builds. So it becomes a parallel builds. So each build will check for their own cache, and then the ones that has changes will only the ones that runs. So this is quite uh like a big uh or a huge work. I think that's a term. Like it's a huge work. So I'll not be able to. I'll be not. I'll be. I'll. Well, I can't really demo it here because it involves infrastructure and um stuff and clusters, and we are still also like trying our best to solve this problem. But it works, and they have solutions. They have given us like, I mean, they have open source um, implementations of the remote execution specification. So actually there are multiple projects for this, but the ones, I mean the ones that the Basel, like the official Basel group GitHub group, GitHub org uses um, build farm. So I think I'll give the links after. Next. So I'll think the next step would be to like just set up a simple um, Bazel's like a Basel scaffold, and just see how it works, and how the like how the configuration works. Um, so I'll create a new project, Basel, and then so based on the presentation, we start with the workspace. So this is where we declare our platforms and tool chains. So what that means is if we have like a Node.js project or a Python project, we need to declare here that we are using Python, so that Basil will know that what we are building is a Python project, and it will also give the necessary um, environment for it to run, because Bazel doesn't really use your local file system directly. So what it does is it creates an isolated process, and then it mounts certain parts of your file system as read only. So in that way, you can't really mutate the files in the project. So I think that's one key. So files are immutable in Bazel. And I have, or we have problems with web-based frameworks because of that rule. Because Next.js tends to mutate files on build. So let's see. So the build configuration uses a language called Starlight, and we don't have the time to like have like a separate discussion for a separate language. So I think we'll just see it as like a syntax. So we start first with the workspace syntax. So it just declares that we have this workspace called Bazel demo. And then in order for us to retrieve the dependencies that we need, Starlight has this load function that calls certain common tools, and then we will import HTTP archive. So HTTP archive is the one that pulls the dependencies that we will need. For example, we have rules Python. So rules Python is a set of rules that the Bazel community provided for us so that we can do run, create, so we can run Python files, run Python tests, create Python libraries. And since Bazel is agnostic, we the community need to like create this from scratch and like have its own way of porting or like integrating how we do Python development into Bazel. So this is just a set of code inside, and then we will just call them by functions. And then if we are using our Python favorite package manager called pip, then we can also add that load pip install, and then we have and then we will call pip install. So if we have like requirements here, requirements for dependencies, then you can add your Python dependencies in this file. And then we can start with like creating a simple Python project. We can call it project Python. So we will add our build definition inside this this project using the build file. So Bazel will check these files like workspace and build. These are reserved files, and we will define here how our tests would run. So there's no compilation on Python. So compared to like TypeScript and the ones that we are using at the company, so I think this will be like more linear. So that's why I'm using this as an example. So we can load same. We will import the rows that we need. So for this one, we will use PyTest to run the certain tests in Python. And then name. So name is it's like a holder. Like you can call this rule through its name. So we can call this test, and then add the files that are needed for testing. So we'll name it test.py. And then I think we can just add a file that's So I think let's just create a file that retrieves your like platform, the name of your platform. So you can import platform here, import platform, and then you can create a a method that returns the platform's uname. And then we will then export this method for it to be accessible on the test file. So we will name it main, and then import sys. And then what we will do next is create the test file. So if you are into like testing and TDD, so you will appreciate adding tests into your projects class. So let's just name it test main. Then unit test.test case. So let's create the test case, and then in the test case, we will test the method. This method should it return the correct value. Then assert self that assert equal main that system. So it should return Linux because I'm using Linux, and then make it runnable. Let's see if this runs. So the command for Bazel is you will need to access the path, and our path is project Python, and then call the rule name. So test. So let's run this one. Hopefully it runs. So not found. Oops, am I in the right folder? Project Python. Test not found. Oh, okay. Wait, I think there's erroring out. I think we need to set see if this runs. Project Python test. Oh no. Okay. Forgot. So Basel test. So in order to run the test, you need to use the test command. Basel test, and then call the test rule. No such attribute. SCRS. 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 Name test. SCRS. Test.py. Why is it not working? Okay. So yeah, the test passes. So you can also add other CI checks like linting. So we are big on linting because JavaScript has TypeScript and JavaScript has good support for linting. And then we also have TypeScript builds when we transpile TypeScript into JavaScript code for it to run in the Node.js platform. And then we also add deployment scripts into this. So so that creates like the entire CI/CD workflow using Bazel. And yeah, I think that's it.